námsbrautarstjóri í landslagsarkitektúr við Landbúnaðarháskólann. Ég landslagsarkitekt, hef verið að reka teiknistofu í 25 ár og ég líka gjaldkeri heimssamtaka landslagsarkitekta og það kannski útgangspunkturinn. Það sem skiptir máli það að við erum í samstarfi innanlands og við erum í samstarfi við erlenda aðila og það náttúrulega frábært að fá svona fólk til að koma sem að vinna akkurat við það tiltekna viðfangsefni sem hér í dag og fá bara svona aðeins púlsinn hvað að gerast erlendis. Svo ætla ég líka að bjóða sérstaklega velkomnan meistaranema í arkitektúr frá Listaháskóla Íslands. Mjög ánægilegt að sjá ykkur hér og þannig að ég ætla bara að vona að þið hafi ánægja af í dag. Og ég ætla að gefa núna orði til hennar Ullu sem eiginlega hugmyndasmiðurinn bak við þennan viðburð og ber ábyrgð á því að við erum með þennan einstakling hérna til að fjalla þetta málefni. Gjör svo vel, Ulla. Og ég gef þér boltinn yfir til þín.
Hello, everybody. I was prepared to speak English. Are there any English-speaking people except our guest lecturer? Yeah, okay. So I'll keep it that way because he will speak English. My name is Ulla, and I'm a landscape architect. I graduated a long time ago from the university in Denmark. But I have been living in Iceland my whole adult life, actually. So I am both Icelandic and Danish. I'm very happy to be that and proud. And I'm very happy to see all of you today. I didn't expect so many. But this seminar, or this preparation of it, started some years ago when I read an article about circular economy for landscape architects in this very good, what is it called? Magazine, Landscape. My friend Torben, who is a landscape architect, and he's running a big company in Copenhagen. It's called Lyt today. So he wrote an article about the circular economy, and I thought, wow, this is really interesting and it's really urgent for us to know more about it. I just thought for myself, I really want to learn more. So I wrote Torben, and he said, no, I'm not the specialist. You should talk to Jakob Sandel. He is the one who knows the most of the subjects in Denmark. So I contacted Jakob, and we wrote, and he was, and I was telling him about I wish just to get him to Iceland to teach us and tell us about his experiences. Where is Jakob? There. Hi, Jakob. But then COVID came, and we just quit the conversation. But some years ago, when COVID was kind of leaving us again, I thought, well, I can't just let this idea slip out of my hands. I need to follow up on it. So I contacted Jakob again, and he was really positive to go on with this. And then I took contact to Samane here in the university and Fila, and so we have been talking together and been preparing this seminar today. And this is, of course, a very urgent subject, and we all need to be together in turning the big ship. We are on a journey in the wrong direction, and everybody needs to stand together to turn the ship. But I would also just like to point out the lesson to be learned from my point of view in this journey here. from when I started getting my idea is that if you get an idea, and you want to do something, stick on to it. Don't let it just slip out of your hands. Follow it up, and dreams will come true, or things will really happen. And I believe that when we all together, take hands together and make an effort to turn the ship, it will happen. So thank you again very much. And Landscape is a fantastic magazine for landscape architects. Read it. Okay, so maybe just, Jakob will continue. Okay, where do I turn this off? Just put it here.
Maybe we need some tech support here, I think.
I think also when to get the technician.
Okay, I can just introduce myself, maybe. Can you hear me? Without the presentation. My name is Jakob Sandell Sørensen. I'm also a landscape architect. Also graduated from what is now Copenhagen University. It used to be an agricultural college, much like this one. I'll just talk slowly so the technicians can get here. In my daily life, I am a practicing landscape architect. I work at a private consultancy company in Copenhagen, and we also have offices in Aarhus. There we are. Can you put it to full screen, or do I?
I don't know how to put this in full screen.
Control. Oh, I just like that. There we go. Okay. Where was I? I work at an office called Schönherr, a private consultancy. We are planners, landscape architects, also a few regular architects, building architects. And we do all kinds of planning and urban planning, urban design, landscape design. We do historical gardens, we do modern climate adaptation projects. So a lot of different things in our portfolio. I'm going to be talking to you about circular economy, or circular economy is a big subject. So I'm going to try to focus on how can we apply circular economic principles in landscape architecture. Maybe in particular in Nordic landscape architecture, maybe in particular in Danish landscape architecture. So some of the principles I'm going to tell you about today are maybe not directly applicable in Icelandic contexts, but I think if you think about it, then you will be able to see a logic in it. I'm going to try to explain why we are talking about circular economy. Why is it important? I'm also going to try to explain what it is. And then I'm going to show you some examples of how we are working with this subject in our own office and in general in landscape architecture in Denmark. So a set of guidelines, you might say, or a set of questions that we ask ourselves and our clients and our collaborators when we develop and work with our projects, in order to try to make them as sustainable or as circular as possible. And as it says here, I'm also an associate partner and the head of sustainability, which means that it's my responsibility to kind of develop the strategy for sustainability in general in our company, but also try to make it work in all the projects. So, to begin with, you've all heard this phrase, I'm sure. There is no planet B. But have you ever really thought about what it means? Because what it really means is that all we get is this one. This is all there is. Everything that we have ever built and everything that we are going to build is already here, or is still here. It's a closed system. It's a finite system. It's like a spaceship. It is, in fact, a spaceship. So some of the things we call resources, natural resources, are limited. We only get a certain amount, the amount that is already here, apart from the odd asteroid. But this is what we have to work with. Some resources are renewable, but only if nature is healthy and thriving. And that's the key point. That's what circular economy means. So the best picture I can give you of circular economy is actually this. And understanding that it's a limited system, and we have to make everything work within this system. So all the natural resources we are ever going to get are already here. All the waste that we have produced, all the waste that we will produce, is still here. Which begs the question, how much is enough? We all tend to want more, right? Bigger, better, faster, more. But if we realize that we live in a limited system, then we need to ask the question, how much is enough? When do we have enough? And why is that important? Because right now we're spending more than our planet can regenerate. Sorry? Any questions? No? This graph shows you the development since clever people started measuring our strain on the biocapacity, you might say. This is an expression of how much our overdraft is, you might say, on the biocapacity account of the entire globe or planet per year. So back in about the time where I was born, in the beginning of the 70s, we were almost balancing. We were not overspending any more resources than our planet could regenerate or not generating any more waste than our planet could absorb or could handle. But it's been going one way since then. To a point where we are now spending just a little more than, on average, just a little more than 1.7 Earths or biocapacities per year. And the small blip that you are seeing on the green bar in 2019, can anyone guess what that is? COVID. That's COVID, exactly. So if you add this difference, you can see that we may need something like 7 or 8 COVIDs per year, every year, to offset the overdraft that we have right now. If you remember what COVID was like, you can multiply that by 7 or 8, then you have the challenge that we're meeting, that we're facing right now. So it's serious, but it's actually more serious than this, because this is an average. This is, if you divide this overdraft on everybody on Earth, we are spending about 1.72 times as much as we should. But in our part of the Earth, or in the northern hemisphere, it's much worse than this. For some reason, Iceland is not on this graph. And I've been trying to find out why, I'm not sure. I think it's about giving up data voluntarily, and for some reason, Iceland doesn't want to give up the data yet. But to compare, this is an illustration showing you a term that is come to known as Earth Overshoot, or Country Overshoot Day, Earth Overshoot Day. So the day a particular country has spent its part of the resources. If we divide all the resources, all the biocapacity per year, evenly, nations like Qatar and Luxembourg have spent their part already in the beginning or middle of February. And in Denmark, we exceeded our maximum by the end of March the 28th. So this is a top 10 or top 15 that we're not very proud of being on. But the other thing is that almost no nation on this graph is actually in balance. Everybody is overspending. Even some of the poorest nations on the southern hemisphere are still overspending. So this is obviously not sustainable. We need to do something to change this. And sustainability is not a new idea. We've been talking about this for many years now. One of the most recent editions of a global framework, this is perhaps the first time, this is a globally agreed to framework defining sustainability, is the SDGs, Sustainable Development Goals. This is the Danish version, but I'm guessing you've seen it before. This is as far as I know, the first time this comprehensively, at least, that we've actually defined and set up a set of measurable goals defining what sustainability is on a global level. The thing that is still a problem with this set of guidelines is that it's human-oriented. Anthropogenic is the fancy word for it. So it centers about what we need as humans, as our species. It puts our species above all the other species. Perhaps a better way of illustrating the SDGs is this diagram. It's known as the wedding cake or layered diagram. Now this divides the SDGs into what you might call an ESG model, like an economic, social, and governance or environmental a way of looking at sustainability. But what's most important perhaps is that it recognizes that some of the goals are more important than others. Some of the goals are the foundation for everything else. In other words, if we do not have a functioning and healthy and thriving nature, we will not have civilized societies. We will not have an economy to drive it. What we call economy is nature. Everything comes from nature. At some point, we've extracted something from nature, processed it, and sold it. We've invented money to exchange these natural goods. The economy is nature. So if nature stops working, everything else falls apart. Which is why today I'm going to focus on the environmental side of the problem. But realizing that it's all connected. So if you don't have this, then none of the other things are going to happen also. So how's it going? Well, I just told you that it's not going very well. This is another example of how, as Ulla said, we are on a tank. I would say we're perhaps in a racing car and accelerating towards the edge of the cliff. This is a projection of global warming, and what we need to understand about greenhouse effect is that every single ton or every single gram of greenhouse gas that we add to the atmosphere is going to add to the problem. It's a cumulative effect. And there is a delay in response. So even if we stop emitting CO2 now, if we stop breathing, all of us, turn off all the lights, stop spending any energy at all, it's still going to get warmer for a couple of years, maybe a couple of 100 years. Even if we stop emitting and start extracting, start storing carbon, it's still going to get warmer for a couple of years. It's a delayed effect. And every gram we emit is going to add to the problem. If we keep doing what we do today, if nothing really changes, the projection is that by the end of this century, we're going to reach global warming temperatures of about 2.7 to 3 degrees warmer than pre-industrial temperature levels. And nobody really knows what that means, because this is a world that no humans have ever inhabited. So this is a serious problem that we need to fix or do something about. Another perhaps even more serious problem, oh, thank you, is the other crisis, the other big crisis, the loss of life, the biodiversity crisis. This illustration shows you a survey, a tally, if you like, of different groups of animals and plants. And the red and orange and yellow parts are the vulnerable or endangered to critically endangered parts of these animal groups or plant groups. The gray part is the statistical uncertainty, so lack of data, actually. And the green and light green parts are the percentages that are doing okay, you might say. So on average, somewhere between 10 to 50, 60% of all species are under critical pressure, in danger of disappearing. Some are in danger of disappearing completely, forever. In short, more than about 1 million species are in danger of extinction right now as we speak, or rather a couple of years ago. So it's probably not better since then. And why is this a problem? Well, it's a problem not just because these species are disappearing or at risk of disappearing. It's a problem because everything is connected. So we depend on a rich and robust natural world. We depend on the food chains that these plants and animals provide. We depend on the medicine that nature provides. We depend on a functioning and thriving nature to resist the spread of disease, to counter the effects of climate change. So when this disappears, we are removing the foundation beneath everything else, ourselves included. So this is a very serious problem, perhaps even more serious than climate change. And of course, they affect each other. If the natural world is less robust, climate change is going to be more violent. The effects of climate change are going to be felt more. And climate change helps to push the extinction of some of these species. Climate change is changing the bioregional zones of the planet. It's changing everything faster than some of these, or many of these species, have the time to adapt. These are delicate systems that took thousands, sometimes millions of years to evolve, and climate change is happening much faster than that. Maybe some of you have seen this illustration as well. This is another illustration of the level of shit that we're in. A research center called the Stockholm Resilience Center, led by a Swede called Johan Rökstom, was instrumental in defining these 9 primary boundaries of, let's say, natural systems or natural dynamics that are critical to the well-being of our planet. And the safe operating zone is defined by the dotted line. And as you see from this diagram, more than 6 of these 9 boundaries have already been exceeded beyond what is deemed to be the safe operating space. So we are putting more pressure than what scientists say that our planet can handle. on many levels. So actually, it's not updated, but I think the current version is more like 8 out of 9 boundaries have been crossed. And what they are looking at are things like biodiversity, about the water balance, about climate change. One of the ones not quantified yet is particular of pollution of the atmosphere, you might say, from different kinds of things. Actually, liquid droplets or water droplets are the main problem, or the main reflector, or the main driver of the greenhouse effect. But water droplets are formed around small particles, so airborne particles. So this is airborne pollution. We don't really know how bad that is right now. Novel entities. These are man-made chemicals, man-made, you could say, non-natural materials, things like plastics, for instance. We don't know yet how big of a problem that is, but it's probably a much larger problem than we realize right now. So there's enough to take on, let's just say that. So, but before we get to what we can actually do about this, we need to talk about why this is happening. Are we really that stupid that we don't understand that we depend on the rest of nature? Well, what's going on? Well, apparently we are, or at least we seem to have forgotten something. We need to talk about modern economics or unnatural growth, you might say. If you look at a typical growth pattern in nature, it could be anything. It could be the development of a species over its lifetime. It could be the development of a particular habitat, or anything really. A normal growth pattern will look something like the green curve here. You have an initial phase where a species is struggling to get foothold. It's introduced to a new environment. Maybe something is predating on it. It's struggling to get a foothold. But once it gets a foothold, it increases quite rapidly until it reaches a natural ceiling, the natural capacity of the particular habitat, the amount of food or whatever. And then it kind of flatlines. Then it reaches a more balanced level. That's a natural growth curve. The only thing that doesn't adhere to this or respect this is modern capitalist economics, you might say. That's more like the red curve. We are talking about economic growth as something that needs to grow 3, 4, 5, maybe 10% every year. But these are accumulated effects. So if you draw that on a graph, it becomes an exponential rise. And what does that mean? What does economic growth mean as we define it today? It means the extraction of more and more raw materials from nature. It means the production of more and more waste and pollution at the end of life of our products. Some products are even designed to fail. They have, by design, a limited lifetime in order to drive growth, economic growth. So this is not a healthy way of defining growth. We need to redefine everything really, but starting with our economies. If we do not redefine the way we think about a balanced economy, then everything else we do is going to fail. Because this is just accelerating faster and faster and faster every year. And why is that? Well, it's probably, at least partially, because of some of the stories we tell ourselves about our role in the world and our position in the world. At least through much of modern times, some would say with the invention of language, maybe, or at least with the invention of the plow, but certainly with the invention of industrialized production. So about 100, 200, 250 years ago, this really started to accelerate. We've been telling ourselves the story that man, just above the woman and the blue whale, is at the peak of the pyramid. We are masters of the world. Everything else is here for us. Nature is an endless pot of gold. We can just keep taking as much as we want and discard it when we're done with it. This is at the basis of almost every modern religion. And when I say modern, it's like plus 5,000 years. The last 5,000 years. Every modern political movement, almost any ideology or philosophy. This is at the heart of it. God created the world for us and put us in it to rule everything else. We seem to have forgotten something. We seem to have forgotten that really, we're just part of a larger system. And that right now, we're taking up much too much space. We're putting a much too large pressure on everything else. So we need to relearn something from way back in the past in order to better balance this system that we are not just a part of and not just masters of, but depending on for our own survival. So what is a circular economy? This is one model of a circular economy. You recognize the same diagram with the 9 planetary boundaries. That's the outer part of this diagram. The inner part is a similar set of boundaries, you might say, but these are minimal social boundaries. So again, it's a human-centric diagram. But this is a set of boundaries defining what do we need as humans in order to live a decent and nice enough life. What's the level of education and food? What's the access to food and housing, and what level of equality should we have as a bare minimum? And in between is what has become known as the donut, for obvious reasons. It's kind of like a Goldilocks zone, you might say. A zone in which we reach our basic needs as humans without putting too much pressure on the natural world. So sort of a balanced equilibrium, a zone in which we get what we need without destroying the rest, basically. So that could be a model for a more balanced future economy. But in order for this to happen, we need to change everything. Starting with all the rules that we made ourselves, defining how we live our lives and how we act in the world. Donut economics. So, if we zoom in on our own part of the world, our own profession, these are the Danish numbers, but I'm guessing that the numbers look almost the same in Iceland. Currently, in Denmark, we are per person spending about 4.25 biocapacities budgets per year. So we have an overdraft of 300% In the construction industry in Denmark, we are using up approximately 30% of all new raw materials, all new extracted raw materials, natural materials per year. 30% of this goes into housing or into construction, not just housing. It's houses, bridges, roads, everything. But we are also emitting just under 40% of all the pollution, you might say. This is translated into CO2 equivalents, but it's really everything. It's pollution in terms of greenhouse gases, but it's also waste. We're generating about 40% of all waste per year from our part of the business as usual model, you might say. And that's without counting what we call excess soil. I'm not sure how big of a problem that is in Iceland, but it exists here, I know. But in Denmark, it's a real problem. When we build something new, we tend to remove what's there to begin with, for some reason. I'll try to explain some of the reasons later on. But we transport a lot of soil, we call it excess soil, or waste, put it somewhere else, and then we replace it with new raw material, sometimes virgin raw material, so newly extracted material. This is the way we think when we build. Sometimes it's a matter of not having the space to reuse what's already there. But basically, it's just to be sure. To be sure that what we are building will last as long as we hope it will or say it will. To be able to calculate on the lifetime of what we're building. If we add what we call excess soil in Denmark, then we generate something like 70 or 80% of all waste per year. So it's almost double the amount. Or at least double the amount, actually. So our business, our industry is responsible for a very large part of the problem. And therefore, we also have to take responsibility for an at least equally sized part of the solution. We have to find ways of doing better. We have to start not just talking, as I'm doing, but actually doing something. We have to move away from this way of thinking. This is an expression of any project development plan you've seen before. It could be a waterfall model, but it's a linear model. That's the basic message here. We tend to think of a site or a new project as empty. We can start from scratch. We can erase everything and start from scratch. At some point, when we've developed a design, we add a lot of new raw materials in order to construct or build what we want to build. Then we use it for a number of years, sometimes many, sometimes few, and then we tear it all down and it all turns into waste. That's the way we are operating now, the standard operating procedure of construction as it looks now. It's a linear model. But if we accept that it's a limited planet that we're living on, we cannot keep extracting new raw materials. We will run out, and we cannot keep producing the same amount of waste. We have to create a system that does not generate as much waste and does not need as much new raw materials. Preferably a system in complete balance where nothing is waste. Everything is reusable and recycled. That's a lot more difficult than it sounds. We have to move towards something that looks a little bit more like this. So to think about any site as not empty, but containing value to begin with, and to think about any project as a bank of future resources. Resources to be made available for future use at the same location or elsewhere. And we have to think of this as a design problem, because that's actually what it is. And that's why it's very relevant for people like us to address these problems, because much of this is down to decisions that we take in the design phase of project development. When we design, we choose materials. These materials leave a footprint. This decision means something somewhere else to someone else at some point in time. Maybe it's already been done. Maybe the tree has already been cut in the Amazon forest. It's already been transported and processed at a lumber factory, and we can just buy it as ready boards. But that decision to choose to use tropical wood has already had an impact somewhere else. When we design our structures, our constructions, the way we combine materials has an effect in the future. It has an effect on how easy these structures are to repair, to maintain. How much of these structures need to be replaced and how often. All of these new material and energy inputs leave an environmental footprint somewhere in the future. All of these are design decisions. So we can design our way out of this, at least partially. We can influence the systemic changes that we need in order to be able to design our way out of this. If we start creating a demand for a more circular way of producing and a more circular way of building, then this is going to happen, then the industry is going to respond. Now, some of you may have seen this or been introduced to this before. The head of the Danish Association of Landscape Architects visited Iceland a couple of weeks ago, and I think he was talking about this guide that we've created in Denmark. This is a way of talking about circular principles or circular economy in landscape architecture. You don't have to take a picture of there's a slide with a QR code later on, so and you can get the presentation later on always. It's not an original language. We've used. We're standing on the shoulders of work done by an organization some of you may know called the Ellen MacArthur Foundation, which is one of the main players in defining and explaining what a circular economy is, in fact. They developed a model targeting what you might say or call traditional production companies. So companies that extract or buy an extracted natural resource, a raw material, transport it to a factory, transform it into a sellable product, transform it to a store, and sell it on from there. So like a traditional linear production company. The Ellen MacArthur Foundation defined 4 general ways of talking about circularity. If you wanted to change a traditional production facility or company into something more sustainable, more circular. What we've done in the Danish Association of Landscape Architects is try to translate these 4 principles into something that we can apply in construction, in landscape architecture. So ways of talking about circularity when thinking about designing your projects or rationalizing afterwards about your projects. And the first one of the 4 is what we call the inner circle, or den nære cirkel. And this principle is about what I said earlier, actually. How much is enough, or how little do we need to change, actually? When we start a new project, there is always something there, or almost always something there to begin with. Maybe it's not roads or buildings that can be reused. Maybe it's just soil. Maybe it's natural occurring plantings. Or maybe it's a good geology or the way the water flows on the surface or through the soil. If we understand the site well enough, we can avoid building into problems in the future. So the inner circle refers to decisions to retain or change retain as much as possible, as it already is on site, and change as little as possible. If there's already a road where you're going to do something else, then why make a plan where you move that road to somewhere else? Why not use that as a constructive, what's that called? Constructive problem, and say, okay, we need to reuse this road. We need to create a plan around where this road is already. Because then we do not have to turn this road into waste. We do not have to replace it with new materials, so sometimes virgin materials that we have to transport and use energy to transport into on-site and reconstruct the road somewhere else. So the inner circle is preserving as much as possible as it is, preferably on-site. That's one principle. The next principle, long-term circulation. This is actually about design. This is about designing for longevity, for a long lifetime. And there are many ways to do that, of course. I'll get back to that a little later on. But anything you do, any design and construction decision that you make that will allow for easy maintenance or easy replacement of parts of the structures, and easy eventual disassembly and recirculation of these structures in the future. Anything that you do in order to maintain the lifetime of these structures. That's what we call long-term, or that's what we've translated long-term circulation into. Cascaded use, this refers to many of the materials that we can find on project sites that are actually recyclable or reusable in some way or form. Some may need a bit of refurbishment or physical change before we can use it somewhere else, but in many instances we can find reusable materials on site. And we should do whatever we can to reuse them, preferably on site, and refurbish them on site if possible. Cascaded use. And of course, our main point is also trying to keep individual materials as pure and unmixed, unpolluted as possible, because that makes them easier to reuse. Some materials actually gain value if they are worn in a particularly nice way, for instance. In Denmark, when we dig up the old granite pavings, street pavings, someone put a layer of asphalt on top in the 60s because we got too many cars. But underneath many places, there are still very nice worn granite paving slabs from several hundred years ago. They are worth more than if we buy them from new today, because they are worn so nicely. So we wish we hadn't put that asphalt on top in the 60s. Anyway, pure circles, trying to keep the individual materials as pure and unmixed as possible, will extend the possibility of their reuse in the future. Now, this is the slide you need to take a picture of if you want to access the English version of this set of guides. It's not just a guide, it's actually also a collection of examples. So there is a collection of projects, and we've used the language of this guide to try to describe the level of sustainability in these projects. So this is a place to begin, you might say, if you don't know how to get started on this. You could try to think about these principles when you design, when you rationalize what you've been doing in the future. It's not really measurable, but it's a way to start. All good? But if we want to take it a bit further, if we want to, I'm going to show you now some of the things and some of the principles that we are working with at our own office. So some of the things that we are questioning ourselves and our clients and our collaborators whenever we develop a project. Some of the things that we are questioning about our prior work. We are trying to learn not just from what we are doing now and doing in the future, but also from the mistakes that we've made in the past. So, and the first principle is, if it ain't broke, don't fix it. If something's already there that is directly reusable, keep it. The less you need to do, the better, the lower the impact. This sometimes scares people because we make a living from changing things. I'm going to argue that we can make a living from changing as little as possible instead, or being smart about what we change. If it ain't broke, don't fix it. So for instance, we've talked about this earlier. Most sites contain value of some sort. If you look hard enough, if you understand the physical micro properties of the site hard enough. It may be in the soil, it may be something you cannot see. You may have to do detailed survey and detailed analysis in order to understand the value of this site. I forgot to, I wanted to pose a little quiz for you, but I've answered the question myself this way. So I usually start, or sometimes start, a lecture like this by asking, what's the most sustainable thing we can do? And the answer is nothing. That is always the most sustainable action. Change nothing. So preserve as much as you can and make sure, or try to make sure, that you get on the project in time to save these things, because that's also a relevant problem for us. I'm guessing it's the same in Iceland. The plans are already done, and then we kind of add a little bit of greenery at the end, right? We need to be in to begin with. Actually, we need to tell the architects and the engineers where the roads and houses are going, if it's going to be a really good and sustainable project. Because we understand parts of the site that they do not see. It's not that they don't care about it, they just don't understand it. Everything you preserve doesn't turn into waste. Everything you preserve requires no new materials, no new energy input. And often, not always, but often it costs very little to preserve or protect these existing structures, if you plan for it in time. Another institution in Denmark that has been focusing on the impact of construction, more specifically building construction, is an institute under the Royal Danish Academy, the architecture school in Copenhagen. And they've devised a catalog, a pyramid. You know, I don't know if you have that in Iceland. In Denmark, we have like what we call a food pyramid, right? And beef is at the top. You need very little beef, and you need a lot of fiber and a lot of plants at the bottom. This is the same principle. This is looking at the embedded carbon footprint, I'll explain what that is, of normally used construction materials. You can't see the illustration, but that's not the point. You can go check it out. There's a website, and I'll send you the link in a readable font size. Now, what we've come to realize about the environmental footprint of construction, in particular about buildings, is that we've become very good at managing the energy side. Once a building is in use, we use energy to heat it or to cool it, and we're very good at building very energy efficient buildings. which means that the environmental footprint of the energy input is managed very well. What we've come to realize is that there is also an upfront environmental footprint, which is embedded in the materials that we choose to build from. Because these materials are extracted from natural resources somewhere, they are processed, they are transported, they are built into a construction, all of these things have an environmental footprint, which is embedded in the materials. Before we even start to build something from them, they have an environmental footprint. That's what you call embedded carbon, or the embedded footprint of materials. And what we've come to realize is that the size of this embedded footprint is actually much larger than we may have thought about earlier. And that, I would argue, is particularly true of landscape structures or construction in terrain. Why? Because we don't use energy to, well, maybe you do because you have abundance of energy. Maybe you use energy to heat up the roads to keep them ice free. But we can't use energy for that in Denmark. We don't use energy at all in the same scale during the lifetime of a project. So the size of the embodied carbon or embodied footprint is much larger compared to the cost of running, of the energy input of running the project in construction projects than it is in building projects. So we as landscape architects, if we want to reduce fast, and we do because we're in a hurry, we need to focus on the materials that we are designing with because that's where the main footprint is. Again, it's a design decision. We are working on creating an extension of this to include the materials that we use in the construction industry, so things like stone and gravel and asphalt, things like that. So hopefully we will be able to present a new version of this when we get the funding at some point. But you can go, it's an online tool, so you can go play with this. But just remember that the lifetime is also important. And how you design your individual structures is also important, at least in terms of how easily reused or recyclable and maintainable they are in the future. So that's what it says here. The detail is crucial, but remember lifetimes. You need to remember to design for disassembly or design for easy maintenance. Now, I've been talking about this already, but sometimes, or quite often, I would say, the operational phase or the using phase of a project is the longest. That's certainly true of landscape projects. We have a design and construction phase, which is maybe 5-10 years if it's a big project, but then this project is in use for at least 30 years, sometimes 50 or maybe even 100 years. So we need to design for that part of the lifetime of the project. We need to remember and to accept that we don't know what's going to happen to this project in the future. But we can make it easily maintained. We can try to make the level of required maintenance as low as possible. And we can design our structures and our facilities to have a maximum lifetime, or a balanced lifetime, you might say. But because if we're using renewable resources, then lifetime maybe isn't that big of a problem. So designing durable constructions with a long life, because that requires fewer new resources, fewer new energy inputs. And it's all about minimizing the environmental footprint. You can see this as all, that's perfect. On my screen it says in a very, very light gray, less is more. Maybe a little bit too light gray. Less is more, you've all heard that saying before. Ludwig Mies van der Rohe, I think, is credited for saying that back in the 20s or 30s, something like that. And I think he was talking about his very minimal architectural style. But actually, it's quite a good slogan even today when thinking about sustainability. How little do we actually need? Less is more, because the less we use now, the more is available for the future. Identify whatever is reusable. Could be anything. Yeah, we've talked about this before, so I'm not going to go into that. But this is important. I'm betting it's also important in Iceland, with all the mountains you have. As I said earlier, we are moving a lot of soil around in order to build what we want to build, whatever we want to build, where we want to build it. So whatever you can do to balance that soil within your project site, the better. The more you can reuse on site, the better. The less energy you need for transportation, the less waste you create, which needs to be managed somewhere else, and the less new, often virgin raw material you need to import to your site to build something new. Now, this is easier said than done, of course, because often the problem is that we don't have the space to manage soil sustainably. We cannot just dig it up and put it where we want it in one go. We don't have the operating space, the logistical space at a construction site to do that. And that's one of the main problems why we are creating this cycle, or this loop of waste and replacement right now. It's not sustainable. So we need to talk not just to ourselves about how we plan the construction process and how we design the project. We also need to talk about the systemics that the often publicly managed structures that handle waste and surplus soil. And we need to talk about if we're working for a bigger client, say a public client, can we start 3 or 4 or 5 or 10 projects at the same time? Plan them at the same time? Make sure that they can exchange resources from one site to another. So it's kind of a small banking system, you might say, of resources. Making sure that as little is wasted as possible. So trying to create structures, often public structures, systemic structures, systems of waste management or resource management that designs waste, that removes the waste from the equation, turns waste into resources. That's what we need to work for. So for those of you who are publicly employed, this is a very important task. But soil is also important for a number of other reasons. Perhaps one of the more surprising reasons is actually how much takes place in the soil, in particular in the biologically active part of the soil. So usually about the top 50 to 120, 150 centimeters. This diagram, I'm sorry about the quality, I'll try to read what it says. This diagram is looking at the carbon storage capacity per hectare of soil in different natural systems, you might say, or climatic zone habitats. So, and what's important is that, imagine that this is the surface of the terrain. This is what takes place visibly on top of the soil. This is what takes place in the first 1 meter below surface level. So a temperate forest, which would be something like, if you had forest, it would be something like this, stores about 57 tons of carbon per year in the visible parts of the plants. But almost double that is in the soil. If the soil is healthy, if the soil is allowed to regenerate itself. In general, the colder and the wetter it is, the better. So I'm guessing large parts of Iceland has a huge carbon storage potential. Naturally occurring wetlands, bogs, moser, I guess you call it in Icelandic as well. These are actually the most efficient carbon sinks that we have, naturally occurring carbon sinks. But only if this soil is kept intact and is biologically alive. If we process it mechanically, if we plow it every year, if we turn the soil every year, if we change the crop every year, then we are not allowing for a natural root system to grow, for this carbon to actually be stored and recycled and slowly recycled in the ground. So soil, in particular intact soil, is quite important, which is an example of a resource that we may overlook completely when looking at a new project site. We don't think of soil as important or as valuable like this, but in fact it is. The wetter and the more difficult it is to build on, the more natural value it actually has. So maybe we should start trading these carbon credits from these ecosystem services, you might call them, which is a bit sad. Anyway, this is also an old design adage, right? KISS, keep it simple, stupid. But this is really about not complicating things too much. When we design, we tend to think that we are original thinkers. We need to come up with a new idea that no one has ever thought of before, right? We all tell ourselves this stupid lie. But really, what's the most sustainable solution is to design simple structures that can be repaired. So structures that consist of as few materials as possible, as few layers as possible, and are joined using simple, preferably mechanical solutions. So stop casting things together, gluing things together, welding things together, because that means we cannot take it apart, or at least we need a large energy input in order to separate the materials again for reuse later. If we can design simple structures, they are easier maintained and repaired, and therefore the chance that they have a longer lifetime is higher. This also means that we should stop creating individual site-specific custom designs. We should use standard building materials in standard formats as much as possible. Why? Because they will probably also be available in the future. If we create an elaborate paving design using different stones from different parts of the world in strange cuts and shapes and sizes, the chance of being able to maintain and repair that in the future is quite low. So I'm sorry, but you need to think hard about which places, which sites actually need a special design. Perhaps we just need to create a better level of basic design in most places. I'm going to be in trouble when I get home for saying this. This I've talked about earlier also. This principle I'm sure you've heard of earlier, design for disassembly, which basically means when you are designing your construction parts, you need to make sure that the individual materials are as available for future use elsewhere as possible, so that they can be easily disassembled. Again, stop casting and gluing and welding and creating I don't know if you use this in Iceland. In Denmark, for some reason, it's become more and more popular to create fixed pavements, like cast in concrete, right? The engineers say they're much more durable. That's why we do it. This has a traffic load equivalent to an airport. We need to cast it all in concrete to make sure that it doesn't move. But the problem is, it does move. Where we are in Denmark, we have a large fluctuation in temperature and in humidity, which is the worst thing you can do to any construction material. That's the worst wear you can put on any construction materials, because it means that things expand and contract, and expand and contract, and expand and contract. And what happens to a rigid structure, if you expose it to that? It cracks. Once it cracks, water seeps in, it freezes to ice, the crack expands, and the problem gets worse and worse and worse. And what's worse is, you cannot reuse the same materials, because it's cast together. You have to start over again. So stop doing that. It's stupid. Design unbound pavings, unbound structures, so that you can at least reuse the same materials on site to repair it. And don't have to start over again. And any engineer who says it won't last, just say, so what? At least we can reuse the same materials to rebuild it again with a much lower environmental footprint. Designed for disassembly. Now, this is one of the novel entities I talked about earlier, plastics. We all know that plastics are a problem because they are not biodegradable. We don't really know if they're ever going to disappear. But it turns out that our industry has a much larger part of this problem, is responsible for a much larger part of this problem than we thought perhaps earlier. Because more than half of the microplastic particles that we find in the ocean, for instance, stems from plastic paint used in the construction industry. And this plastic is everywhere. It's in our bloodstreams. It's in the food chain, so it's in us. We are slowly turning into plastic, Barbie and Kens. And we really do not know the effects of this long term, but it's probably not good. So stop painting things. Even if it's just to make them last a little longer, don't do that. Increase the thickness of the material itself so that you have a bit of structure that can decay or wither away without losing structural integrity instead. Don't paint, don't galvanize, don't stop using these chemical surface treatments if at all possible, because they create waste, very harmful waste in some cases. Speaking of waste, we need to start thinking about, actually we need to stop using the word waste. We need to just call it resources or materials. We need to plan for the reuse of materials in order to not create waste or increase the amount of waste. And remember that anything is actually reusable. Even cut-offs from plants or grasses that you cut off. We had a discussion last night at Ulla's about all the plant waste that is disposed of in a huge unsorted pile, and then you just leave it there to rot. This is actually natural fertilizer. You can reuse this on site. If you plan for the facilities to turn it into mulch or to what do you call that in English? Oh, anyway, rainwater is another example of something that we've considered waste. We need to get that into a hole in the ground and into a pipe and out to the sea as fast as possible. We don't need to look at this. This is a problem. But why? Sometimes, maybe not that much in Iceland anymore, but sometimes we actually have seasons where we need waste, or need water. Where we need to water our plantings in order to make them survive, particularly if they are newly established plantings. In Denmark right now, we are seeing a quite dramatic expansion of the extremes in weather patterns. So we're not just seeing a lot more rain, a lot more heavy rain in parts of the year, we're also seeing much more drought and higher temperatures in general. So we have summer periods where we don't have enough drinking water. The farmers are restricted in their watering capacity, and you cannot water your garden. So we need to think about water not as waste, but as a resource, as a valuable resource. And we need to make space to retain this water, to keep this water for when we use it, for when we need it. So that we stop using drinking water, pure water, to water our plants with. It doesn't have to be pure. It could be from a lake. Again, that's basically what I said. So even green waste or plant waste and rainwater, something which we don't perhaps think about as waste, but something that is generated over and over from the projects that we create. We should be able to recycle those and reuse those on site. Imagine if we could create projects that didn't need additional rainwater for irrigation, or didn't need additional fertilizer to make the plants grow. If we could just create a naturally balanced, closed cycle on site, wouldn't that be beautiful? We all know this is true. We're landscape architects, right? Green is good, and it's a pleasant color. But green is actually really good for many reasons. One is carbon storage, I showed you earlier. So we need to plan and design for the maximization of green space and the minimization of gray space or paved areas, if you like. This is easier said than done, because we need to get people on site in their cars, perhaps. We need to have spaces for them to leave their cars. We need to have footpaths from where they leave their car to the entrance. Some of them also drive bikes. They need a place to park their bike. All of this requires paving. Maybe sometimes there's a fire. You need to create access for the fire engine. This also requires paving. Maybe the building architect is an idiot. So he's placing a lot of entrances all around the building, 10 meters in between. That means we have to have a paving all around the building. So if we want to plan for less paving, we need to think about how we compose the design on site. And we need to think about how we solve these flow patterns, how we combine the functions that require paved areas. And that also entails questioning current legislation and ways that we usually do things just in case of an emergency. But if we manage to do that, we get so much more and from so much less money, actually, from the plantings. The planted areas provide so much of what we need for very little financial input, very little effort, actually. I've borrowed this from our friends at Greenpeace. Some of these are actually true, some of these are not. But in general, these are some of the positive effects that plantings provide, planted areas provide, perhaps in particular large trees. Now, I know it's a problem in Iceland with large trees, and I'm not quite sure why, because if we look out the window, you actually have quite a few large trees here. Maybe it's because of the accessibility to water and a good soil, I'm not sure. Maybe it's just because you're fucking farmers like we are in Denmark, right? They block the view. They give shade. They're shading my crops. They provide shelter for wildlife, which is destroying my crops. So unless I can shoot it and earn money from shooting it, I'm not having these tall trees. I'm just going to cut them out. But this is happening even in urban areas for some strange reason. Because in urban areas, we really need large trees. Why? Because we have so much paved area, so much built-up area. And this is often constructed from materials that retain heat energy from the sun. This is what the effect is known as urban heat island. I think the next diagram will show you an example of this. So the sun heats up the roofs, the road surfaces during the day, and this heat is then released during the night. So the temperature in urban areas are often quite a lot higher than in the surrounding landscape because of the lack of greenery, because of the lack of shade, of canopy cover from trees, because of the lack of evaporation from soil or transpiration from plants, which helps reduce the ambient air temperature. You know this perhaps from supermarkets, right? You enter to the greenery section and they have these vaporizing systems in there. That's exactly the same effect actually that large trees has in an urban environment. It increases the evaporation or evapotranspiration, which is the combined effect of those two things. It takes up some of all that excess rainwater that we get sometimes when it rains a lot more with climate change. Plants actually feed off this, so why not let them? It removes and binds some of the particular pollution in the air. So pollution from cars or dust, whatever, is binded to the surface of leaf matter in particular. Now, one of the ones I don't agree with is this one. It reduces noise levels. No, not in any measurable sense, anyway. Psychologically, however, if you can block the source of the noise with a nice planting, then you might not notice the noise as much. But it's nothing you can measure. That needs soil or something else, something bulky that will absorb the noise. So trees, plantings in general, but trees in particular. In particular, of course, indigenous species, trees from evolutionarily local habitats. Which is also a truth that I would like to modify just a little bit, because with climate change, we are seeing the shift, a very rapid shift in what we call bioregional zones right now. They're moving north, all of them. So in Denmark and in Iceland, it will, in a very short period of time, you will be able to grow plant species here that you haven't had before. And you may need to use them because you will have conditions, particularly in dense cities, where it's impossible to use indigenous species, or at least indigenous species alone. So you have to think about creating plantings which may include a degree of what we call exotics or not indigenous species, but choose species that are not too aggressive, species that are not too dominant in their development. So think maybe more about how to balance the planting through design and through maintenance in order to avoid that an invasive species or a non-indigenous species becomes an invasive species or a dominant species. This is the urban heat island effect diagram that I showed you before. Sometimes up to 10-15% higher temperatures in urban center areas than in the surrounding landscape, simply because of the lack of canopy cover, of shade, and of evaporation, primarily. So green is good, and the denser the city, the better it is, actually. So stop cutting down trees farmers. But what about beauty? Is it all just a rational, let's do whatever we can for nature? But what about what we also pride ourselves in being able to create? Something beautiful, something that has a value which is perhaps not as easily measured. I would argue that beauty is equally important. The problem, of course, is that it's subjective. Everyone has their own idea about what is beautiful. So it's much more difficult to design for. Is this beautiful, for instance? Yes. Some would say yes. Some would say no. What's that? This is one of our own projects. This is actually a rainwater management and cleaning facility. It's basically just a hole in the ground. Basically, we dug up the soil, made hills that you cannot see, put the water in the ground, and let nature take over. This is storing and cleaning rainwater before it's expelled to a natural stream, which is at the row of the trees behind. So you see, this is also like a dike. This is what defines the maximum capacity of this natural or nature-based solution to rainwater storage and cleaning. And being landscape architects, of course, we shaped this. We tried to give it, tried to integrate it in the terrain and make it seem like it could have always been there, but it is obviously man-made by design. Is it beautiful? Maybe. We also do stuff like this. Is this beautiful? It looks a little complicated. If I was the paver, I would be a little. And these trees look a little bit strained, don't they? Yeah, I have to have a talk about my colleagues in Aarhus about that. Maybe freeing some of those trees in the future. This is the cathedral in Ribe in Denmark, which is one of the oldest cities in Denmark. From back in the good old days, in the Viking Age. So this cathedral is, I don't know, 800, 900 years old, something like this. Now the problem with Ribe is that it's based in a part of the country that is slowly sinking into the sea. Groundwater is rising and seawater is flooding more and more often. So this is actually not just a paving, it's one big permeable sponge, earth sponge. This church is built on wood pilings. If we dry out the subsoil, the church is going to collapse. So we need to keep the subsoil moist at all times. So this paving is actually designed as a bowl, completely against what we would normally do, as a bowl pointing towards the facade of the building, and with permeable grouts, so that the water can permeate through the surface and keep the soil humid. So it's not just a sustainable solution to the rainwater management of this, it's also preserving cultural heritage. But again, is it beautiful? That's debatable, I guess. But what's not debatable is if we can create projects that are so well liked, so well received, that they require maintenance, that they get the maintenance that they require, perhaps even at a high standard, that extends their lifetime. So in a way, a beautiful project, or a project that in general is perceived as beautiful and is used, has an actual purpose and a function, that has a much higher chance of being loved and therefore being maintained and therefore gaining a long lifetime. I'm almost done. I think it's gonna fit just nicely. Sharing is caring in a high-pitched yellow. I've talked about this before. If we think about projects as common ground, really, as something that we are building from building blocks that is on loan to us at this point in time and at this place. These are natural resources that we are making use of right now for this project, but they're not ours. We cannot waste them. We need to make them accessible for future generations as well. We need to do everything we can to not just minimize waste, but actually eliminate waste, design out waste. And that requires changing everything, actually. This is an example of another studio project. This is actually a waste reclamation center. And it's not just a circular building. It is a circular structure. It's also built from almost 80% recycled materials. So the in situ cast concrete you see here is recycled concrete. The asphalt pavings you see are recycled asphalt. There are a few structural steel beams in the roof sections you see there, which are new, but everything else is actually reclaimed materials. Now it's easier, of course, to do this when you're working for a client who makes a living from collecting and sorting garbage or waste, right? But the purpose of this project is also to serve as an example. So it's definitely not a cheaper way of doing it, but in the long run, maybe it's a much better way of doing it. And it serves as an example. So there's also a small schoolroom where local schools from the municipality can come and learn about recycling and waste reclamation and things like that. So it's not just a functioning, active waste reclamation facility, it's also a teaching facility, you might say. It's just outside of Aarhus. If any of you are in Denmark, we will be happy to show you around. Now this is perhaps, I haven't talked so much about the planning scale, maybe the initial phases, if you will, of project planning. But there are also things we could do at that point in the project development to ensure that creating sustainable solutions become much easier later on in the process. And one of the things is to understand the scale of the site you're working on. Now, it's quite difficult to explain and understand, but when we're talking about sustainability, what makes sense to define as sustainable actually changes or can change quite a lot if we change the scale, the geographical scale, just a little bit, or if we change the time frame that we are looking at. So for instance, if you get a new project site and you look at the boundary line defining that project site as the boundary for your sustainability plan, you don't look at anything outside your project site. That will define what makes sense to talk about as sustainable. If you're only interested in part of your site, maybe there's an interesting planting or some interesting structure that you want to preserve, that changes the scope of what's sustainable in your project. If you want to create really sustainable projects, you should look outside of your project site. You should make sure that what you bring in your project is something that is lacking in the regional context. A new function or a new connection, a better connection to the surroundings, something that has been missing, and not something that is competing with what is already there at your neighbors. but something that adds to the site and the context in a positive way. And also, so this understanding of mapping what's missing, what's not there, how can we improve with this project, and how do we avoid creating a detrimental competition with our neighbors. This will also solve a lot of the problems that you have, the discussions or arguments you have with your neighbors, because you're building a new set of luxury apartments just like theirs, just a little bit better and just in front of their view, right? There's no need to do that. So thinking about these things already, actually before you begin drawing, but just as understanding as part of the programming for your site or for a competition. Thinking about adding to the context outside of your own project limits, that makes it a better and more sustainable project. And the chance that your neighbors are also going to like it will increase. So, to sum up, I have 1 minute, which is perfect. Circular economy or circular principles in landscape architecture is basically about 3 different things. First of all, let's get rid of expressions like waste and pollution. Let's try to design out waste and pollution, or at least minimize it as much as we can. Let's try to design solutions that keep already extracted raw material in circulation for as long as possible. So minimize the need for new raw virgin materials. While doing that, let's try to regenerate some of the nature that we've destroyed in the past as well. But first and foremost, let's stop exceeding the planetary levels. So, in fact, we shouldn't in Denmark be building anything new since the end of March. Because if we don't do that first, then none of this will matter. If the economy just keeps growing as we've been as we've been growing it since or until now, then this doesn't matter. So we have to respect the limits of the system that we are part of. Does that make sense? Thank you.
My name is Helena Guttormsdóttir. Nice to see you all here. I know nothing about circular economy, but now a little bit more. But I think, of course, it's a huge task. But in COVID, we could change things in a few weeks. So we can also change things. We just have to, talk to the politician, maybe in a way. But I just wanted to tell you, Fila is inviting everyone who wants to lunch at 12 o'clock. But the program now is that we're going to divide you into groups, 8 groups of 5 people. And I'll let you have the name after coffee break who are in each group. We are trying to mix people with a different profession and different backgrounds. And then we are going to take a walk around the village, Hvanneyri. And of course, maybe did you get the files in the architecture from the Ramsar area? Because Hvanneyri is a special place in a way. It's a Ramsar area, so we have a lot of birds, wetlands, and etc. And we are also just going to take a walk from here to the kindergarten, wasn't it, Ulla? Yeah, Ulla is maybe more in charge of that. And also into like a private gardens, and we are going to have a look at different themes like materials and what do you say, texture and circulation and water management, and then take around to the old houses and back here, I think. So
Primary school.
Yeah, primary school, yeah. And then after lunch, we are going to have a workshop where we just have coming up ideas with a new solution. I'm not an expert, I'm not excusing myself. So just how can we, I think this way of thinking is far away from my daily way of thinking. So I think just talk together, have ideas, and maybe take pictures of what you see. And you can also send an email to me, and we can maybe print out picture of materials and so on. And first of all, have an inspiration. And this is not the first time he's coming here. We decided that last evening. He's coming again. Okay, after 2 hours. So have a coffee break now, and I will divide you into groups. Ulla is going to say something.
Yes, because I realized there are a lot of people here not knowing Hvanneyri. Maybe it's your first visit, so I just wanted to point out to you that despite of the small size of this village, it's quite an unusual village because we have here a kindergarten, primary school. In this university, we also have this college level of education, and then the university. And we have the graveyard, the church, and museums here. And maybe 20 years ago, before the university became a reality, most of the inhabitants here were working in the it was called the farmer school, or I don't know how we translate it. But today, all kinds of people are living here. So we are not only a university campus. So Hvanneyri can or represents just every village or city, because we have so many structures here. So that is just, what I wanted to point out.
I think we have a coffee and then we gather in here just to have, focus on the things we are going to look at and also the groups.
Exactly. So now it's coffee.